So we're being asked to choose two positive integers, m is greater than n, such that these four, as many as possible, are prime. Now, the way I would go about this question is just to try the two smallest positive integers. That seems to be a good starting point. So I'm going to go with m is 2 and n is 1. So that is then true. I'm going to then get that m plus n is 3, which is prime. That's a good start. M minus n is going to be 1, which by definition is not prime, in fact, because it has to have two factors. We don't consider 1 to be a prime number. You might want to look more into that because it is actually a definition. M times n is then going to be 2, and m divided by n is also going to be 2. So here I've managed to get 3. Is it possible to get 4? That's the thing. Now, as soon as I change the primes to something else, like I suppose I could try 3 and 1, but then I would get, if I tried 3 and 1, then as soon as I add these two together, I'm going to get an even number. So I've now realized that we have to have an even number and an odd number. So, and the only prime that's even is going to be 2. Of course, we could try 4 and 1, but as soon as you then times these two, you're going to get a composite number. 2 is the um, only even prime number. So that's not going to help. And what I'm trying to do is just argue why we're not going to get any more options. The answer is actually going to be 3. So I've ruled out 3 and 1, so it has to be because then I won't get an extra one. There's no way I'll get 4. If I try 4 and 1, then that will mess up. And then as soon as I start trying things where I don't use 1, then when I times these two together, even if they're two prime numbers, then I'm not going to get a prime number here. So basically, I've argued, even though there might be other options where I can get 3, there's definitely no way to get 4. All four of them prime. The most I can get is 3.